I think so. We're definitely live. Okay, so today is 4/24, and today's objective is proving parallelograms with parallelogram theorems. Okay, write that down, please. Proving parallelograms. We're going to prove parallelograms with parallelogram theorems, okay? So what we had in our reading out of our journal is 4 different theorems. We're going to write them down, okay, so we can see them. So proving parallelograms, okay, we're going to have to use our 4 theorems. So to prove something, you've got to have a law or a rule. In math, they're just our theorems. Theorem's a fancy word for a math rule that can be proved, okay? So we're going to actually use these theorems. So let's see, the very first theorem we had, one was our parallel opposite side converse theorem. So I'm going to abbreviate, and you guys can abbreviate too, okay? Those are my parallel opposite side converse theorem. And what does it say? Just that if the opposite sides are equal, it's a parallelogram. That's my first theorem, right? Parallel opposite side converse theorem. If I have opposite sides that are equal, it's a parallelogram, okay? And our second one was, our second theorem was our parallelogram opposite angle converse theorem. Okay, so that's our second one, is our parallel opposite angle converse theorem, okay? What does it say? Just exactly what it says up here, that if the opposite angles are equal, it's a parallelogram, okay? So if we have this, we have a parallelogram. It's that easy. Okay, third thing we have, our third rule, our third theorem was our opposite side and parallel congruent theorem. So it says, if you've got, they're parallel and equal, just one pair though, one set, parallel and equal, it's got to be a parallelogram, right? It's got to be. So if that's what we have, that's our evidence, then we can say, boom, it's a parallelogram. And then the fourth one we had was our parallelogram diagonal converse theorem. And that one says, if the diagonals are bisected, boom, it's got to be a parallelogram. Okay? Pretty easy. So let's first of all take a look at this example, okay? So, number one, we have to prove it's parallelogram. So let's draw it first, okay? -3, 3. There's A, okay? 2, 5. 1, 2, 3, 4, 5. There's B. 5, 2. 1, 2, 3, 4, 5. 2. There's C. And 0, 0 is D. Okay, let me go ahead and draw my parallelogram in. Actually, it's not a parallelogram yet. Let me draw my quadrilateral. It's not a parallelogram yet. I have no proof. Looks like one. Just like Cameron looks like a guilty guy. Doesn't mean he is. So we need proof, right? Well, there's a couple of ways to prove it. We have all 4 of these proofs. So here it is. It's not a parallelogram yet. We need to prove it. So we can do one of these 4 to do it. Now, for me, personally, the easiest way to prove this is that the opposite sides are parallel, because I can find their slopes, okay? I could find the lengths by Pythagoras theorem, okay? And I'm going to go through this, okay? There's several ways to do this, okay? One is I can find the lengths, but I have to use my Pythagoras theorem, okay? And that takes a lot of work. That'll work, but it's a lot of work, okay? I could get the diagonals, but to prove they bisect each other, I'd have to prove they have the same midpoint. That takes a little bit of work, okay? I can prove that this is parallel to this and these two are equal. That equals what? The angles are really hard. You need trigonometry. We don't know how to do trigonometry yet. So what's the easiest one for me, personally, is the slopes. Because I can count the slopes up 2 over 1, 2, 3, 4, 5. Up 2, 1, 2 over 1, 2, 3, 4, 5. Same slope, they're parallel. So let's show that. So if we are a fancy mathematical attorney, slick attorney of mathematics, we'd say, okay, here's how I'm going to prove it. First of all, I'm going to say slopes. I'm going to go by slopes. I'm going to say the slope of AB, if I count, up 2 over 1, 2, 3, 4, 5. 2 over 5, right? Okay, so the slope of AB is, I can count it. It's rise over run, up 1, 2 over 1, 2, 3, 4, 5. So the slope is 2 over 5. Now, what's the slope of DC? Okay, the slope of DC, let's see, that's going to be up 1, 2 over 1, 2, 3, 4, 5. So, Your Honor, Counselor Davies would like to say that AB is parallel to DC. Check the evidence. The evidence suggests that if they have the same slope, they're parallel. I've proven something, haven't I? I'm not done because it's not a parallelogram yet. All it is right now is a trapezoid. It's just a trapezoid right now, okay? So what do I have to do? Okay, so let's look at the slopes of AD. So my slope of AD is down 1, 2, 3 over 1, 2, 3. It's down 3 over 3. And then the slope of BC is down 1, 2, 3 over 3, down 3 over 3. So, aha, Your Honor, Counselor Davies can say that AD is parallel to BC. Okay, now I'm pulling out the big guns. I'm going to use my theorems. I say, Your Honor, I can say that, court of law, I'm going to state the following. I'm going to say that ABCD is a parallelogram by, and let me write this in different color, by my big statement, by my parallel, opposite, side, parallel, actually by its definition, take that back, by its definition, which I need to put up there, by its definition. And I need to put the definition up there. I just about lost one from you. Let's put number 5. If opposite sides are parallel, it's a parallelogram. I forgot one. That's an important one, right? By its sheer definition, if opposite sides are parallel, it's a parallelogram. And I did that by its definition, okay? Proven. It's a parallelogram. That's the easy way to do it. I don't want to do the hard way. Why do the hard way? We can just walk into the courtroom, be the smart guy or the smart girl, prove your case, and walk out. Okay, let's look at number 2. Okay, guys, return the page. Does that seem pretty easy? So I knew a parallelogram had to have parallel sides. I found slopes. They have equal slopes. They're parallel. Okay? Got to be parallel, right? Equal slopes. Should we turn the page? Okay, number 1. Okay, so is it a parallelogram? Well, let's make it a parallelogram. So how are we going to make it a parallelogram? Well, one of the things I would do is if these two angles add up to 180, so let's find x. Let's make it, so let's go 3x minus 20 plus x plus 40 equals 180, okay? So let's make it equal 180. If that equals 180, it's got to be a parallelogram, right? Let's force it. Let's force it to be a parallelogram. So I said, okay, let's make this angle plus this angle must be 180. Let's find the value of x that makes it 180. I'd have a 4x plus 20 equals 180, right? Minus 20, minus 20. I'd have a 4x equals 160. Divide by 4, x is going to be 40, right? So if x is 40, if I put 40 in there, let's see, I'd have 40 plus 40 is 80, totally right. So this angle is 80. This angle is 100, right? And we could find a y. If I wanted to find the value of y would have to equal, so I know that 4y would have to equal 100, right? Because opposite angles would have to be equal. So y would have to be 25. Okay? It's a parallelogram. It's a parallelogram because I know that adjacent angles add up to 180, and I have opposite angles are equal. Okay? Thumbs up. Okay, let's look at example 2. Okay, one thing I've got already is that these two sides are equal, or parallel. This is parallel, okay? If these two sides are equal, then I'm going to use this theorem, right? I want to use this theorem here. I've got the parallel sides. Let's force the two sides to be equal, okay? Let's find the value of x that makes these two sides equal. So, all right, 10x plus 7 equals 12x minus 9, okay? Now let's solve. Minus 10x minus 10x. 7 equals 2x minus 9. Plus 9 plus 9. 16 equals 2x divided by 2. X is 8. So if x is 8, this side's going to be 87, 87, okay? So I've proven already that they are parallel. How have I proved they're parallel? I'm using this theorem right here. Equal sides, parallel. Equal sides, parallel. Now what about y? What's the value of y? It's got to be 106 because we know it's a parallelogram. So y has also got to be 106 because these two are opposite angles in a parallelogram are equal. So I proved it was a parallelogram. Then I could say, well, these got to be equal because it's a parallelogram. Almost done, right? Example 3, right? So I think what I want to prove, I want to show the diagonals are equal, right? I'm going to show this. So if I can show that these two sides are equal, these two sides are equal, then it's got to be a parallelogram. So let's force them to be equal. Let's take x first. So if I say, okay, 6x plus equals 4x plus 10, right? And what I want to do is find the value of x that makes them equal, okay? It's easy. Minus 4x, oh, sloppy, minus 4x. 2x equals 10. Divide by 2, x is 5. Okay? So if x is 5, then this side is 30. And this side is 30. Hey, those are equal, right? Okay, but now, I don't know about the other, but let's force them to be equal. So let's figure out the y. So, okay, let's go 2y equals a y plus 1. Okay, that's easy to solve. Minus y. Minus y, I've got a 1y equals 1. So if y is 1, then this side is 2, and this side is 2. Forces it. It is a parallelogram. It's a parallelogram by that theorem. Does that seem pretty easy? So today, the only thing we're doing is this. Let's make it a parallelogram. Yesterday, we said, hey, we have a parallelogram. Today, we're going to say, let's make it a parallelogram. Yesterday, we said, we have a parallelogram. Do you see the difference? Hopefully. Okay, that's all I got, and we have plenty of time to get some work done.